So thanks for coming. My name is Jean-Paul. For the last year, I've been working on a React marketplace web app for Africa, where the average network level is like the slow 3G we had 10 years ago. So just to make it work, not any fancy stuff, we had to apply a lot of things that are from the progressive web app trend, and this is what I'm going to talk about today. So what is a progressive web application? The definition on Wikipedia is pretty blurry, and you can understand pretty much anything you want from it. So basically, it's a concept that wants to keep up to date with the latest technologies, and your app might be progressive today, it might not be in 6 months from now, depending on what Google decides. So what is the real thing nowadays, and what can we do today to have our app progressive and performant? One of the definitions is that it loads instantly. Instantly is, of course, a dream that we have, but we tend to be close to it. So we will discuss a lot about server-side rendering, what an app shell is, and how we can optimize it. A progressive web app should be offline ready, which means that even without any network, the user should feel like everything is still working and life is great. So we'll discuss about service workers, a little bit about optimistic UI. And the third point is user engagement. So this we won't discuss because this is more for marketing people than developers. And it's about your web application being able to receive push notifications, being dockable to the desktop, etc. These are very standard things that you can apply copy-pasting snippets, so there's not much to discuss here. So what does loads instantly mean? Right now, each of you, if you're a front-end developer, is working in one of these three technologies, and probably a few more icons will appear next year, because why not? With all these great frameworks, our apps became very complex, have great interactivity, but the problem is that to get to the app, it first needs to load. So you need to load your whole app in the browser, all the JavaScript bundles, or your CSS bundles, before the user can interact with the application. So if you consider use cases like e-commerce, where a lot of people use mobile on a not so great network in countries where well, the network standard is much lower than in in Europe, this becomes a problem for user engagement. So let's go to server-side rendering. So what is server-side rendering? This is a pattern for a normal single-page application. The browser hits your index.html main page, then it downloads everything, and we have a loading, and then only after a few seconds, your user gets some interactive experience. Server-side rendering, the idea is that we are going to trick the user into thinking that he gets the app before he actually gets it. So basically, instead of sending an empty index.html with just scripts and bundles, we are going to generate viewable HTML, so this part, on the server side, and send it to the user directly with all the styles and everything, so the user sees something right away. It still doesn't work, it's not interactive because the browser in parallel still needs to load all your bundles, but the user thinks that he has the app and can interact with it. So this is the concept behind server-side rendering. And the other thing we are going to talk about are service workers and app shell. So basically, service workers is a new API that is supported by Chrome and Firefox. Safari and Edge do not support it, of course, yet. And basically, the idea is that the browser can load a JavaScript file that does not run in your application, but runs in the background of the browser. So there, you can do a lot of things. To install the service workers and use it, it's extremely simple. You copy-paste this to your index.html. This SW is your JavaScript file. And a service worker looks like this. So this is a service worker that actually tells the browser to cache all these files as soon as they are loaded. So basically, regardless of whether your app is running or not, the service worker works. So this caching layer is beyond your app. It's in the browser level. With the service workers, you can also, this is how you can receive push notifications, so the user is notified even if he's not on your page. So basically, the service worker concept is that you put a JavaScript background task in the browser. Now, how can this be used to improve the performance of our app? Because push notifications are not really performance, right? So we have the concept of app shell. So in a web app serving content, the app shell is basically all the things that do not change. So here, the logo does not change, the header does not change, the categories do not change. The only thing on the New York Times that changes if you hit F5 10 times during the day is the content of the articles. So here, the concept is that we tell the browser via the service workers to cache everything that is part from the shell. So when you hit F5, the user, he actually sees this instantly. There is no network call, no checking if the cache has expired on the CDN, etc. This is instant, and then the content is loaded. So service workers with caching and server-side rendering are the two concepts that, well, major concepts that make your app progressive. So now, let's see if it's worth the effort, because again, this is just a trick, right? The user, he actually wants to see the content and the end thing, be able to interact with your application. So it might not be worth the effort to do all this if it doesn't provide any value to your users. So if you are working on content-driven apps, press magazine like the New York Times, blogs, e-commerce where engagement is key for the users to see the products right away, yes, it is worthwhile having as much performance as possible, also for SEO considerations. So Google can index your single-page application pages. It is able to do it. But if you have it server-side render with proper caching, you will get a much higher score and a much better SEO for your pages. What it's not really worth the effort for is iteration-driven apps. So if you have a heavy SaaS dashboard or an enterprise app, it's likely that your user logs into your app to perform an action and spend there a few minutes. So if he waits 2 or 3 seconds for your app to load, it's probably not a big issue. And also for this kind of apps, mobile and slow network are not really a use case. So when you think about progressive web apps, don't fall into the trap where you need to do everything just to be trendy. A lot of things are not useful for a lot of use cases. So now, is my app progressive? How can we measure, how can we benchmark the performance of our app? So there's a cool tool called Lighthouse. It's an open source tool. It's available in Chrome under the Audits tab. And here, if you go to this tab and you're on your web page, you just select the areas that you want to be checked. So there's a special checkbox for progressive web apps, and you run audit. And this tool will run a simulation of your app on the mobile, fake a slow 3G network, etc., and give you a score and a lot of indicators of what you can improve on your app. This is open source, so there is also an NPM module. You can put it as part of your continuous integration chain and monitor if the score doesn't fall because, I don't know, you've added some too big images or there are issues in the code. So 55 is a good score. So this is a score that gets the Google homepage, eBay, etc. So this is to show that the progressive web app standard today is already 10 steps ahead of what the browsers can support. So if you get more than 55, well, that's probably not possible today. The report, this is from eBay. The report that you get in the tab at the end of the audit looks like this. So you get 2 scores, but they don't really mean anything if you don't read through. And what is very interesting is that you have laid out all the improvements that you can actually do to your app. So it's a no-brainer to go through and see what makes sense or not. There are a lot of quick wins to be found there, easy things to implement that boost the performance of the app. And this core reflects directly, maybe not one-to-one, but has a big impact on how Google Robots sees your page in terms of SEO ranking. The other thing that is interesting here is that you get a link to the progressive web app checklist. So next time you get to coffee after lunch, instead of going to Facebook, I suggest you read this. It's quite long, but there are a lot of things that, again, really make sense, are easy to do, and improve the performance of your app. The other report that you get is about performance. And here, what is very interesting is that you get all the timeline of how your app is seen by the user under these poor network conditions. So these conditions where we consider that if the app works, it means that it's progressive and it's performant enough. So basically, the two metrics that are relevant is first meaningful paint. So this is the moment where we trick the user into thinking that the app is actually loaded, and the consistently interactive time. So here we can see that on eBay, if a user was on a shitty Android phone from 5 years ago and on a slow network, he will get the page seen at around 2 seconds, and he will have to wait 6 seconds to actually do something with it. So there's in terms of user engagement, there is a 4-second span, which is quite a lot when you think about use cases like e-commerce or reading blogs. Again, in the performance pan at the bottom, there are a lot of so-called opportunities. So all the things that you can improve to improve the performance of your app. So this is a great tool to look at from time to time to see what you can improve. So now let's get to some more concrete and developer level talks, because this was all theory so far. So server-side rendering in React. All the other things that I've discussed, implementing service workers, caching, etc. This is probably something you can do if you start after this talk. By the end of the day, you should have a good grasp of how it works, and by the end of tomorrow, you should have been able to implement it in your app. So these are very simple stuff that you can do and tremendously improve the performance of your app. Server-side rendering is a bit more tricky. If you have an existing app or starting an app in React, there are a few bumps that you will have to hit. So this is what I'm going to talk about now. So what does it take for your React app to support server-side rendering? So first, you need to be able to bootstrap the app server-side, of course. We'll consider that you're using Node to serve your app, which is the standard nowadays. And then there are 4 areas where we need to, again, think if it's worth doing or not, depending on our use case and the value it provides. So we have routing and chunking, data loading, modular CSS, and infrastructure. So bootstrapping your React app server-side. React, well, when it's loaded into the browser, it goes through a whole life cycle, but it also provides us synchronous methods to transform a given JSX app into a rendered HTML markup. So Node.js will just call this renders to string method to create the HTML that we want. You must set up, if you are using Redux or things like that, you must set up stores, middlewares, etc. up front, but this is also fairly standard and copy-paste from the client-side section. You must use some context to actually inject a lot of things like fetch and the store in different places of the application. If you are dogmatic about not using context in React, you can try some workarounds, but it's way easier this way. If you need to handle authentication, what you need to do is use cookies to pass your data or tokens, because this is the only thing that is available to the server when your user first access your web page. There is no context yet, nothing has been loaded, so this is how it needs to be done. And the last thing is that our CSS need to be injected also in the HTML that we are going to render, so it looks good. The end result is something like this. So this is like the My App that you might already have or do when you do client-side rendering. And there are a lot of things around to kind of inject what needs to be injected on the server side. But I mean, the concept is is fairly standard, and your application, as it is right now, except a few things that I'm going to discuss, does not need to be completely rewritten to support server-side rendering. So now let's get to routing and chunking, which is probably the most tricky part if you have an existing app that does not support server-side rendering to move to it. So we need the routers that support async actions as route changes. I'll explain why in one slide about data loading, but basically when you call this render to string method on the React side, none of the React lifecycle kicks in. So you don't have this component did mount, nothing mounts, etc. It's just a one-shot render of your app that gives you an HTML string. So what you need to do is have this data loading and this asynchronous things as part of your route transitions. So all routers, React Router supports it. There's a universal router as well who does a pretty great job. It's very simple to use. So I'll give an example right afterwards. And chunking is, well, I think everyone knows what chunking is. You chunk your app so that every page is a separate set of bundles in terms of CSS and JavaScript. You chunk it with Webpack or whatever package you have, and the router should be able to trigger fetching the missing pieces when you get to a new page in your app. So data loading. This is what I've said before. The React lifecycle does not kick in on the server side. So if you have a client side only React application, in the component demand you probably have either data loading or loading some animations or things like that. So this won't work on the server side, and these are the parts that need to be rewritten, basically. This is what I've just said, actually. So components should not trigger data loading and page-wide animations themselves. Things need to be passed either as props or being in the store directly. And this is an example of how you would do routing in a server-side React application. So basically, this is the action that is called by the router when you actually hit the page. And it's an async function that will use the store to check what's already in there. And if you don't have what you need, you will actually make an async call to your server, store your data in the store. So this is here. And then you will render your page. So your page will always assume that data are in the store. You could pass the data as props to the page, but basically this is an external income. This pattern enforces also separation between the view and the logic of the application. So it's well, beneficial also from an architecture perspective. All right. Let's get to the CSS. So now what do we want to do? We want to trick this user by providing him the experience as soon as the page is viewable and pretty with the CSS. So here, if we put a lot of effort into chunking the JavaScript and having a minimal bundle and a minimal index HTML that is displayed to the user, we can't drag a whole CSS code base with heavy frameworks like Bootstrap, etc. What we need to do is, at a minimum, have a per CSS styles. So basically, same concept than chunking. Each page has its own CSS, and basically only this is loaded as the critical things that need to be served to the user to have a viewable page. And at best, you would use CSS in JS technologies like style components or CSS in JS. There are like probably 15 more out there, where basically your CSS are tightly tied to your React components, so you have even more granularity of what is actually served to the user, and an even smaller index HTML in the end. So this is an example of how this isomorphic style loader works. So basically you import your CSS, which should be, well, the real trick here is to have this modular enough, so if you have one big CSS file, it doesn't work. But if you can split your code base on a component by component basis or page by page basis, you can just import this, and then you you use this with styles mark with your component to tell your app that these styles are needed, right? So if my component was my page here, I would get in server-side rendering, I will get an HTML that has just the CSS for this page and just the JavaScript for this page. So this is what we are trying to achieve. The version with CSS in JS, so this is an example with style components, is even better because you have CSS tied to your lower level components basically. And here this is a small profile picture thing which just displays an image with well, rounded circle, right? So here you can see that it couldn't be smaller than that, right? So each component has exactly what it needs, and in the end you get the smallest bundle possible. Other CSS styling concerns. Well, styling is probably the most difficult things to grasp in the server-side rendering. Keep your application simple. This is not true only for technical reasons, but for conceptual reasons. If we want to have a page that is served as fast as possible to the user, it can't be all fireworks, animations, many colors, many images, because otherwise, well, it will just take longer to load. No large header images. So if your UI or UX designer has the great idea to put a big image on the banner of your page, you can tell them, let's not do that. They probably won't listen, but you can try. Use web-safe fonts. So what are web-safe fonts? Web-safe fonts are fonts that are installed on the operating system, available natively by the browser, so it doesn't need to download them. Again, if your designers force you to use some trendy Roboto-slab fonts or stuff that are not standard, what you can do is only a best effort of telling the browser to prefetch the fonts. So basically, you would put a prefetch link type on your font link, and this will tell the browser to start downloading it right away as soon as it hits the line, without waiting for other things to happen. This is still best effort. There is no guarantee that the font will arrive before the rest of the page, so you might end up under very poor network conditions with a page that has the default font and then the font kicks in, which is probably one of the worst things that can happen, because it looks really bad and the user gets a really bad impression of your page. The last point is responsiveness. So here, if you have a responsive web app, this is also a tricky part, because responsiveness should rely on CSS and use media queries. So on the browser, we do have the screen size, we know where we are. Now we are trying to generate an HTML that is on the server side, and the server has no clue what size your screen is really about. So you can do user agent sniffing. So there are modules like mobile detect or something that will give you, if the user is on a phone, on a tablet, this is reliable, but you still don't get the size. So the 5-year-old Galaxy, I don't know, A3 or A2 is way smaller than the new Galaxy S8, and the server will see them as the same screen. So what will happen here is that the server will generate one version of the app, and then when React kicks in the front end, it will generate another version of the app if, of course, the layout changes between the two screen sizes in your app. So here, the idea is also to keep it very simple, keep your responsive breakpoints with your end users. So if you are designing for, I don't know, if your target are iPhone 6 and high-end users with high-end screens, design for it and drop the smaller screens. If on the other hand you design for smaller screen, design for smaller screen, drop the others, you can't have the best of both worlds, and the server will never be able to guess what is actually the screen size of your application. Right. The last point is infrastructure. So on a traditional web app without server-side rendering, you bundle your app, you push it to a CDN, and for even if you have a high-traffic website, for a few $100s of CDN per month, you can serve the whole world, and there is no problem. Now, with server-side rendering, CDN doesn't really work anymore because every request goes to your server because you need a node or any other server to actually run the rendering, produce the index HTML, and serve it to your users. So you went from one server that is origin for a big CDN, which just works like Cloudflare or Netlify, whatever, to your small server being hit by all the requests of your end users. So if you want to support the same experience, the server cost will just explode if you have a high traffic website. So if you are serving very dynamic content and personalized content, like for example on the Medium blogging platform, where the content is personalized to your user profile, there is no good way around that. So you do need to have a huge infrastructure that will actually support the load that is needed to serve the content properly. If you don't, if you are running an e-commerce website where products are changing but they are not personalized, so the same thing is served to all the users, there is a workaround that. So where is my workaround? Okay, I've lost my workaround, but I'll just say it. What you do is that you use an automation library like Nightmare.js or Cheerio that will actually call your server, which does server-side rendering, produce the HTML file, put it somewhere else, and this file you will serve from a CDN. And if you automate this and regenerate the page every 5 minutes, you get a lag of 5 minutes with how your products, etc., are rendered to your users, but you are still probably thousands of dollars better in terms of infrastructure than if you didn't have that. So there's a slide, sorry. Another point about infrastructure and specifically Node.js. So Node is a mono-threaded server. You can cluster it, throng, etc. Cool, but it's still a mono-threaded server, and each node takes some server space. And render to string is a synchronous method. So there is no I/O there. It doesn't call anything. It's a synchronous method, so it will lock your node thread until it's done. So basically, if your app has a 100 milliseconds render time, which is quite okay, a given node can serve 10 requests per second. So if you have 1 million users per day, again, the costs explode. And this is my workaround, sorry. So this is what I've said before, that we would crawl, basically, we would crawl our website and produce a temporary version that will then be used from our CDN. All right, so a bit of benchmark, and React 16 was actually in the title of the conference, so I needed to have a slide with it at least. So this is a comparison. You have the credits at the bottom that guys made on a web app that was working on Node 4, 6, 8. So we can see that, well, probably no one uses Node 4 now. You might be using Node 6. Just moving to Node 8, which is a pretty safe migration, gives you like a 20% bump in performance in terms of server-side rendering. But what is really interesting is that React 16 gives a 10 times better performance than the previous version. This is because React 16, it did bring some improvements and new features in terms of API, but the main focus of the React guys was to rewrite the whole algorithm that is in React to manage the refresh and parsing the virtual DOM. And they did a pretty good job because it works 10 times faster now. So if you have a React app that have performance issues, forget about what I've said before about server-side rendering, just move to React 16 and you should be good for 5 or 6 months. Then you can move to the other stuff. All right. So a small recap of what we need to do, we need to bootstrap the app server side. This is fairly easy. We need to support routing and chunking. If you don't have that in your app right now, it's probably pretty hard to refactor all the routing, all the chunking of the app. So this is more something that should be taken into account upfront. It's doable, but a lot of work. Data loading, once you have routing sorted out and these async actions, you just move the data loading from the React lifecycle, component did mount, etc., to all the files. So this is a fairly cosmetic job. Modular CSS is hard. If you have a large CSS code base, splitting it, having to render just the critical path of what you need every time your user hits the page might be a hard work. And there is a responsiveness issue that is, well, still quite tricky to get right. And infrastructure, well, this is more clicking on your Amazon Web Services account or something, so it's not very hard, but it can become very costly quite quickly. All right. So, final thoughts. As I've said in the beginning, progressive is a moving definition. So today an app can be progressive, 2 months from now, maybe not. So basically, what I would recommend is to stick to this Lighthouse tool and monitor what's happening. This progressive web apps checklist will be, is enhanced periodically, so you can get new ideas, things you didn't even know about that can be done very quickly to optimize your app. And from all these features, because the list is really, really long, pick the features that drive engagement of your users. So again, if you're working on a heavy SaaS application or an enterprise application, all this stuff are probably not all useful. For example, if you have a SaaS app, push notifications might be more useful than improving the load time by 1 second or 2. So pick your fights, because this is changing so quickly that it's not worth spending weeks and months on things that will change in 2 months, actually. And I'm actually quite ahead of schedule, so we'll have more time for coffee. Thank you.